Hello guys, we are back with our next tutorial. In this tutorial, let us see the pin diagram and the block diagram for 8279. So basically the pin diagram, it has 40 pins guys. So as usual we will be having the 40th pin will be VCC and the 20th pin will be VSS, ground and power supply. And we will be having the DB0 to DB7 right from 12 to 19 guys. Write them from down to up. From 19 write DB7, DB6, DB5, DB4. Those are nothing but data buses guys. Fine. So above them write operation, read operation, reset. Okay. So come on the another side guys. Here 21 we will be having A0, which is nothing but address. Above that chip select. Above that we'll be having BD guys. Okay, BD is nothing but blank display in which there will be nothing displayed on the screen. And above that we will be having 4 outputs of A and 4 outputs of B. A0, A1, A2, A3 outs, out B0, B1, B2, B3. So these are all clear now. So above that we will be having 4 SL. Those are nothing but scan lines, SL3, SL2, SL1, SL0. Above that we will be having shift. Above that control slash strobe. Above that RL0. Above that RL1. And parallel to 39 we will be having on the opposite side RL2, RL3 clock, interrupt request, RL4, RL5, RL6, RL7. So these RL are nothing but the return lines guys. So now I hope everyone got a small idea on the block diagram. So now let us go through, we got a small idea on the pin diagram guys. So now let us go through block diagram. So this is important to remember guys, because this question is asked twice I think so in the previous year papers. So be perfect with the block diagram and pin diagram of this. So basically the block diagram, as we all know, it starts with data buffer first, then input output, then FIFO. They enter FIFO or sensor RAM according to the type of scanner, and these are connected to internal bus to transfer the data. And this internal connection is display address register, 16-bit 16 into 8 display RAM is there, and control and timing register which is connected for each and every block. This control and 8 into 8 FIFO will be there. 16 into 8 RAM will be there. Here sensor RAM or display RAM will be there. 8 into 8 FIFO or sensor RAM will be there. We will be having a keyboard rebounds logic, and display registers are those 4A and 4Bs, timing and control, and we also have scan counter and return. Okay, so now we are done with the discussion of our block diagram and pin diagram. So now let us go through each and every pin slowly, one after the other. So let us start it now. So the first pin is DB0 to DB7, that is nothing but data bus which carries the 8-bit datas. The second one is CLK, that is nothing but clock. The third one is REST, reset, which resets the whole interface of keyboard guys, that is 8279. CS bar is nothing but to select chip select, which should be active if this keyboard interface is on working mode. A0 is nothing but the address line. R, D and W are nothing but read write. IRQ is nothing but interrupt request. VSS is ground. VCC is power supply. SL0 to SL3 are scanner lines. RL0 to RL7 are return lines. BD is nothing but blank screen to clear the display. Output A0 to A3 and output B0 to B3. These are the output ports of two 16:8 internal displays. And CNTL slash STB are the control stops. So this is all about the pin diagram and block diagram guys. So we have already covered these scanner modes guys, scanner, sensor, matrix mode and strobe input output mode in the previous tutorial. So in the next tutorial we will be going through the serial data transmission and parallel data transmission guys. So let us meet in the next tutorial. Thank you. Thanks for watching.